erwischt. Das dusselige Bewerbungsprotokoll gestern nicht synchronisiert oder was will mir erzählen? Ja. Dusselige Nextcloud. Warum kann man denn das denn abgewöhnen? Nextcloud, genau. Das nervt das die ganze Zeit. So, 52. Wir fangen einfach schon mal langsam an. Schauen wir mal kurz. Ich kann es bestimmt hier nicht auf Deutsch machen. Ja, aktuell wäre es sogar möglich, aber hilft alles nichts. Welcome to Distributed Information Systems lecture number 8. As we already discussed, this may be your last lecture for this year, and it's also my last lecture for this year, so our motivation is nearly one level. Nevertheless, we have to talk about some relevant stuff today because it's part of the exercise. And as we have another exercise this afternoon, and many of you may have already solved the RMI problem, we have to do this thing we already did earlier in the lectures. We have to jump ahead to the topic that is relevant for the exercises, do the exercise stuff, then jump back to the theoretical stuff, go ahead the theoretical stuff, and then jump ahead again to do the stuff that is relevant for the next exercise. So don't be surprised if we open up some different slide package today. So we will be talking about servlets in a minute or two. Right, before we do that, let's share some screen. It's this one, so we share this screen, and then we move this one to that screen. And now we have a blank screen, exactly. So let's kurz in dem Zusammenhang, swiftly talk about the exercise that should be conducted today and this afternoon. So most of you should have already finished the RMI stuff, at least the mandatory RMI stuff, because it's rather simple to succeed in that compared to the socket communication. That should be clear by now. This service management is an optional part, so it can be done, but it's not really relevant for the overall exercise. The Echo server that works like an HTTP server is also optional part. So we jump over that today, and you may have some time to work on that next year. So what we will be doing in this afternoon, or you will be doing this afternoon, hopefully, is playing around with ServNet technology, which is a very low-level Java technology to build dynamic web pages on the server side. But we will see that later on during the lecture itself. And as always, we start with a warm-up mechanism. So first of all, we build a Hello World servlet that just prints out a very simple web page. It's just for warm-up reasons, so that you know how to successfully build a war archive, to have the right directory structure and everything up and running, and being able to use the servlet container, and then everything is fine. Before I forget, it's what we need is we need XMPP. So everyone needs to download XMPP for this exercise and the following ones, because everything, the following ones will not use directly XMPP, but we will see the successfully implementation of the exercise using XMPP respectively. When we open up XMPP, we are interested in the Tomcat servlet container. That's the primary goal we are currently facing. So if you haven't installed XMPP on your device yet, you will definitely need that. And as we are not sitting all together in the university and don't share any bandwidth, you can download that now. And then you'll have it up and running during the exercise. Right, that said, going back to the warm-up, so that's a small warm-up exercise. After that, we will have 2 more sort of warm-up exercises, tackling different aspects when we do HTTP communication. 2.2c is getting all the HTTP header information inside the servlet. So read out the HTTP header information that is provided by the browser request, integrate that into a response page, and then sending it back to the browser that is triggering the servlet. It's quite similar to the 2.2a exercise, which you presumably have not yet done. So what we will see in the info servlet is similar to 2.2a. So it should look like this. So you get an HTTP GET request and then some information about the browser and what the browser is capable of. And that should also be conducted with the help of the servlet technology. And this is then called the info servlet. And of course, it needs to be deployed and tested and executed, and the same thing. Then another warm-up servlet, which is called session servlet. So you should play around with the session object on the servlet side. So you need to somehow store the state of your system. And in order to succeed with that, we will be using HTTP session class on the Java side, on the servlet side, and you should play around with that. Aside from the session information, we also want to provide some URL parameters and incorporate that into the result web page. So you provide an URL parameter when you call the servlet inside a browser that is printed here. So some kind of magic number, whatever you want. And the system remembers which magic number you used last time you visited the web page. And then you test your servlet by calling the same web page with 2 different browsers and URL parameters. And hopefully this shows you that the system has a different session for both, for different calls. So that will be another warm-up exercise. And then we come to the real thing that makes up the overall exercise. As I already said on the first exercise and in the introduction slides, we want to provide a web page that is capable of showing data from 4 different servers using 4 different communication technologies between whatever runs inside the web server and the server technology. And currently we have 2 servers. When we are at this point of the exercise, we have 2 different servers up and running. We have a C++ server running, and we have an RMI server running. And this servlet should then use the stubs or the classes you provided to test the communication Java client to C++ server, Java client to RMI server, and the environment service servlet should use both of these classes to provide a web page that looks similar to this. So it should provide an output, what is the current state of the C++ server and what is the current state of the RMI server. So you need to integrate your client programs, Java to C++ client and RMI to RMI client. And when we continue next year, we have a SOAP server environment data and we have a REST server environment data, and they will also be both incorporated into the same web page. So this is a web page that depicts all this. And if one of these servers is offline, then it should, the web page, the web servlet should, of course, realize that and print something like, okay, C++ server is offline. And when the web page is refreshed, which should be done in cycles in task 2.2f or with a reload button, then during this reload phase, the server gets up again. Then, of course, the content of the server should be shown and provided. And that's basically the real target. We want to provide a web page showing the state of the different servers that are running in the background and with whom we communicate or using different technologies. Remote procedure calls, remote method invocation, REST technology, and socket communication. And everything under one hood. And we will use servlet technology to get everything under one hood. Okay, so this is the exercise we want to do. And yeah, this is, and the target of today is, of course, getting as far ahead as possible to 2.2e. It's not that complicated once you have everything up and running. But of course, setting up the environment, getting everything up and running, having a process that enables you to do everything in a swift manner is, of course, a thing. That said, some of you, or not at least half of you, will try to use some kind of plugin for your development environment in order to solve that problem for you. You can, of course, do that, but it's not feasible. It's not feasible because, again, something is happening in the background you have no clue about, which is typically not good at all. And the second problem is, in the exam at the end of this lecture, there will be definitely some questions about how to deploy a servlet manually. What is done under the hood. And if you have never done that yourself, then of course you have no clue during the exam, which is of course bad. And I announced that this is the case. So you have to decide on your own if you really want to use a plugin and just press play and everything is done in the background and having no clue at all what is done in the background, or doing it manually and understanding what is happening in the background. Of course, that's your decision to make. I warned you about the risks. So this brings us to to slide package number 6. So we stopped last time in slide package number 5, and we are now going to speed up or jump to slide package number 6. So, and the topic of slide package number 6 is HTTP and servlets. And as I have extended the servlet part at some point, we may have problems talking about that just in 45 minutes. So we jump ahead, talk about servlets. So we have a good ground to solve the exercise. And when we have the good ground to solve the exercise and still have some time, then we jump back to the RMI stuff, where we will talk about The security aspects, when we load code from a foreign computer on our computer, which typically is a problem. And afterwards about HTTP, and then we are up and on track again. So please open up if you do integrate some comments, slide package volume 6, and we will skip ahead of HTTP and move. And curl will be talked about later on, and we stop at the slide number 28. Number 28 is about web server, just very short remarks regarding web servers in general, and then we continue with the servlet technology. Right, let's do that. So web server, of course, every one of you knows what a web server is. You're using it on a daily basis, and we are all using it on a daily basis. Nevertheless, it's that part or that software in combination, of course, with some hardware that receives, manages, and responds to your HTTP requests of your browser. So you want to surf on a web page, you want to use some kind of web application, web page, and that piece of software is responsible of doing the job, and is called web server. It's in some books it's stated that it's the cornerstone of today's internet. And of course, there are dozens of web servers you can use, incorporate. You can build your own web server, but of course, only few of us will get the pleasure of building his or her own web server. We typically use those that are available on the market, like Apache, IIS, Nginx, GWS, and others that are available. So what's some kind of historical development? When we've already would have talked about the HTTP protocol, which was constructed in the 1990s by Sir Berners-Lee, or the team Sir Berners-Lee worked with. Of course, we started with static web pages. So when I started studying computer science in 1993, the internet wasn't really internet. It was just a few servers and everything was not yet really up and running, but still it was working, and we had some kind of static web pages, and I still have the sound of my modem in my head when I sometimes have a relaxing hour, and beeps of this thing still burned into my brain. Loading some kind of static web pages. After the era of static web pages, the developers quickly realized, okay, this is nice, but it could be better. And they came up with the plugin approach. So some kind of technology was plugged into the web page that were capable of behaving like applications. So that thing what we have today, or where browsers or web applications look like software, behave like real software installed on your laptop, on your desktop computer, was also a thing in the mid-90s last century. And it was the birthplace, for instance, of Java, because Java, and we see that in a few slides later on, was first envisioned and constructed to be a client-side browser incorporated language. And the thing was Java applets. They wanted to have a Java application running in the browser that behaves like a real application. So the idea was already is quite old, what we are currently working with. And of course, it's not only Java technology. Microsoft had something, Flash plugins, stuff like that. And today we are very dynamic. We have very dynamic web pages. We have reactive web pages. We have tons of software that scripts that enable our browser to behave like real software installed on the device. And when we talk about dynamics in web pages, we always have to distinguish between, okay, dynamics that is incorporated on the server side versus dynamics that is incorporated on the client side in the browser. So we get stuff that we can execute in the browser, and then the browser behaves like, or the web page inside the browser behaves like a real application. And it is a real application when we consider all that code that is incorporated. Nevertheless, in this lecture, we are not interested in client-side dynamics. So we are not doing dynamic web stuff on the client side. Some of you have that kind of topics in a different lecture. We will concentrate on the server side and only on a very, very small window on the client side. And our small dynamics window on the client side is the servlet technology, which we use. What we will also hear a few minutes is that the servlet technology, and you will see that quite easy why it is not used the way we will use it, because it's quite umständlich to be used. Nevertheless, servlet technology typically builds the foundation of more fancier Java web dynamics stuff like Java server pages, for instance. They are looking nice, fancy, they are scriptable, they have their own domain-specific language. But when you look, when you push Java server pages up and look what's underneath it, you will see servlets are used below Java server pages. And therefore, and as we don't go into that depth in the server technology on web pages, because it's not really the topic of this lecture, we just use the most simple approach, and this is servlet technology, and is completely enough for our stuff we want to do. I had in times of this distributed information systems lecture where we also used Java's server pages, but due to timing restrictions and tons of other stuff that came into the lecture over the years, so we dropped that, and I dropped that. And this is not part of this lecture anymore, which brings us to the servlet technology. And we again start from a historical approach. So from the applet technology to the servlets, in 1994, Java was introduced. And as I already said, was that Java in the first place was more like a piece of code running in the browser on the local virtual machine, making web pages dynamic the first time. And of course, this in that era was something that was, woo, cool, this is nice, this is fancy. And so this applet technology started the Java hype. And nevertheless, these applets showed us how a dynamic web page, what a dynamic web page could really achieve. But applets never really got off the ground. There were different reasons, like for instance, shown here, you could of course disable Java on the browser side. Of course, we had the version problematics. Is the real runtime environment matching with the applet, with the compiled code? We had some network problems, encryption problems, database connectivity problems, and all that, which hindered applets to really get off the ground. So the applets died rather fast. Nevertheless, the idea of having dynamics in web pages, as we can see today, stuck, and is something we commonly use today and enjoy using today. What we could also see was that Java is a language what was quite easy to learn and nice to use, and even so, the source of Java, this applet technology, died or was not really used anymore. Java itself grew and flourished quite enormously. So starting from a programming language for the web, it became something that was used all over the place. Of course, now Oracle owns Java, and typically everything Oracle buys dies at some point in time. We will see how long Java will prevail, or if Java is already dying and in 10 years everyone will be using some different kind of language. We will see. And this is something we cannot influence, at least not on a personal manner, perhaps as a group, but you and we will all see if Java successfully survives this or will wither and then be exchanged by something else. Which brings us to the servlet itself. It's more like an artificial word. On some web page, I said it was. I read it was a pun. I haven't laughed about that in any way yet, but perhaps at some point it will get to me. So it's server applet is getting dynamics on the server, and they just made servlet out of it. It's part of the Enterprise Edition since the late 90s. And I was asked on Monday if we need to install the Enterprise Edition, and there is a clear no, you don't need to install the Enterprise Edition version of Java. We just need the servlet library and later on some additional libraries to do the rest of the exercises. But we don't need the real Enterprise Edition of Java. It's overkill. You don't need to do that. Of course, some of you will nevertheless do that, and of course you can do it if you like, but it's definitely not necessary. It's officially not even a Java project anymore. It's one of the first projects or modules in Java that has become open source. So it's also not managed by Oracle anymore. It's part of the Apache Software Foundation, and which can be found here. And nevertheless, it is still an integral part of many Enterprise Edition technologies. What I was already stated is when you take a look at the web stuff that is incorporated into the Java Enterprise Edition, and very, very, very down the layer structure, you will find that they quite commonly use the servlet technology to do the last step to the communication. And they have some nice libraries built on top of that. So you don't really see anymore that in the background servlet technology is used and everything is nice and sexy, and in the background it still comes down to we have some kind of servlet up and running and doing the job. Okay, this brings us to what is a Java servlet. When it comes to looking at it, it's a piece of software that enables us to dynamically generate web pages on the server side. And this is exactly what we want to do. And server means web server, not server, C++ server, RMI server, REST server, SOAP server thingies. So that are the servers that are in the background. And I could incorporate here a nice picture showing that. I have to write that down. Layer picture, because that would make it more clearer where the servlet really resides. When you try to remember, I quite often already showed you this client, then some arrows to a web web server, and then from the web server to the servers, and from the servers to the databases. And these servlets, they are residing on the web server. And the web server communicates with the background servers. And this is exactly what we want to do. The nice thing about these server Java servlets is that due to the use of Java technology, they are more or less platform independent, they are protocol independent. And if you have already worked with Java, you know you have tons of libraries available that can do everything you want. So everything is possible, and servlets can use these classes, these libraries in the background. So everything Java is capable of is available at your hands, and you can use it. And therefore, this is of course nice and easy. This is of course something that we are quite fond of. What do we need in order to work with servlets? We need a servlet-enabled web server and something that contains an environment a servlet can live in. And this is typically called servlet container, and sometimes also called servlet engine. So we need a web server that contains a servlet engine, a servlet container. And we will use Tomcat as a servlet container, and Tomcat can also be used as a web server, not a good one, but it does the trick. And in Tomcat, the servlet container is named Catalina. Don't ask me why it is called Catalina. Perhaps the daughter, the fiancé, the dog, the cat of the team lead of the development team was named Catalina. I've got no clue. If you come up with an explanation, I would be happy, and I would incorporate that in the future lectures. But at this point, we have to live with the knowledge that the servlet container in the Tomcat is named Catalina. If you stumble upon Catalina and you don't know if it's a person or not, it may be a servlet container. Inside the system, so this is what we need on the server side. And of course, we need to code a servlet. And in order to code a servlet, we need some specific Java packages, and we need the JavaX servlet and the JavaX servlet.http because we want to do HTTP-based servlet communication. And this is not part of the standard JDK you typically install on your device. It's not part of it. It's part of the Enterprise Edition. Nevertheless, we don't need to install the Enterprise Edition. All we need is the library that contains the code for the servlet technology. And luckily, when we install the Tomcat system on our device, which we will do by installing XMPP, which is available for Windows, Linux, and Mac systems. And of course, therefore, we use that. Then the jar archive can be found in the Tomcat installation directory under the library directory. And there is a jar archive, and the libraries in Java are typically jar archive, which is just the renamed zip archive called servlet-API. And this is the one that we then need to incorporate into our project. And then we are able to build servlets. And there is a demo sign here. So I typically want to show you where to find it. So let's share some screen space. Where do we find that? Do I already have something up and running? No, of course not. So let's open up this again. And let's go to C. Let's go to C. Hey, come on. to C. So I installed my system on C. This is my C partition. And as you can see, there are quite a few XMPP versions already installed. I typically delete the real old ones. Something during installation which you have to be aware of. XMPP likes to install quite high to the root directory. Don't try to install XMPP in some network directory or alike. This typically leads to problems. So this is something you have to or should install on C or D on the highest branch possible. And then if we open up XMPP, we see what's all available in XMPP. And down here, there is something called Tomcat, and there are some start batch files. So we are interested in Tomcat. And Tomcat, we will take a look at the different directories later on, especially for the configuration and the log stuff and the web apps. But at this point, we are interested at the library directory. So here, all the libraries that are relevant are provided. As you can see, Catalina is also present. Yeah, Java server pages are present. And right here, there is the Servlet API, jar. And we need that. And when we do our projects in some kind of IDE, and I will use Eclipse on the Java side. At least I tend to use Eclipse on the Java side. And then you can see in the library section, where have I referenced libraries? Yeah, right here. So this is, for instance, our Hello World program, which we will later see executed. There you can see that I referenced the Servlet API directly in the C XMPP Tomcat library directory in order to be able to use this class and to import the relevant Servlet technologies that are needed here. So this is something we need and which you have to install. So if you haven't done yet, install XMPP because it's necessary. Right. This brings us back to our slides. So going back to presentation mode. So going back to presentation mode. So we need the jar archive to be able to build servlets in our IDE. And then we have some slides regarding the benefits of servlets. Yeah, I already named most of them. It's Java technology. Java technology exists on car radios, on smart cards, on laptops, on smartphones, on desktop PCs, on servers, in games. So Java is everywhere. And therefore, you can use servlet technology everywhere. And there are hundreds of thousands of classes and libraries available, which do nearly everything. Today's problem is not solving a task. It's typically about finding the suitable library that already solves the task. And that is trustworthy, not as this log4j stuffy. So everything is available, and you can copy and paste, and you can orientate yourselves on the solutions other developers have already made and used. So that's a nice thing that can be done. It's rather efficient to be used. It's a technology that has been thoroughly tested and up and running for quite a few decades now, and therefore nice to be used. They are rather secure. And the good thing about the servlet is, of course, and on the server side, Dynamics, is that the code that does the dynamics resides on the web server. So no code, at least not the server code, is communicated to the client, which of course on the server side dynamics, you always have something that needs to be communicated to the client. And of course, when it is on the client side, and if the people that are representing the client side are intelligent enough, of course, you also provide how you did this dynamics. And therefore they can take a look at it and copy it and say, yeah, this is a nice solution, we will use that one. And perhaps your company doesn't want that and wants to keep their secrets and their work hours safe. And this, of course, is also something that is nice. Servlets can be instantiated in different ways. You can have one servlet that is shared by different browsers. So this request represents a singular browser that tries to open up a web page that is triggering a URL. But of course, this URL is not a static file on the web server. It's more or less a piece of code that gets triggered when this URL is chosen. The web server realizes, okay, this is not an HTML file I need to provide. Let's move forward this call to the servlet that is representing this URL sequence. And then this is done and provided to the servlet, and the servlet then checks what the browser wants, generates an answer and sends it back. And you know the drill because we already did this with the socket technology. And so in the background, of course, everything is done with sockets. So we can do something like this. And if the requests, if there are too many requests, of course, we can build a servlet pool where multiple servlet instances work and try to solve the requests of hundreds of thousands of browsers that are trying to reach them. Everything is possible. This brings us to the how do we do the trick part. And this is also something I want to extend, which I realized this morning when I stepped through the slides in order to know what we will be talking about today. What's missing is an overview, what steps need to be conducted when we play around with servlets. And there are 3 steps we need to take care of when we talk about servlets. First step, of course, is building a servlet. We have to code something. The second step is using a technology to tell the servlet container where we stuff in the servlet later on what needs to be done. So we need to somehow integrate some kind of metadata. And this is, in the old days, we provided an XML file that contained the knowledge, and today we will use annotations directly in our code that do the job. And the third step, of course, is if we have the code that is properly annotated or has a separate XML file that does or provides the knowledge to the externals mechanism that wants to use our system, then we have to put it into some kind of package, and in servlet technology is put into a WAR archive. And then we have some kind of installation package. And this is the last step. And when we have this installation package, we can then send this installation package to the servlet container, and the servlet container is happy, unpacks its package, it's present, unwraps it, and takes a look at the metadata and says, oh, I need to start this, and then everything is up and running. So this is missing, and this will be integrated perhaps during this day or at some later point in time. And then next generation students will be able to see some more input here. Nevertheless, this slide package starts with step 1. We need to implement a servlet. Comparable to Android and different other framework-based technologies, we don't have a main method anymore. We have methods that get called by the framework we will reside in. So on create, on resume, on start in the Android world. And here we have something similar. But here it's just the service, the initialize, and the destroy lifecycle methods that get called by the system. What do we want to use later on? There are some classes involved. We are just interested in the HTTP servlet, which is an abstract HTTP servlet class, which we derive our own class from. And then basically we just have to implement the associated lifecycle methods, and then that's done. If you want to check the Java documentation, I have a link provided here that should still be working. Not sure if there's a 0.10 version already, but we are not going into that deep. We are just scratching the top layer of servlet technology, so this should be not a problem. So what's the workflow? Every browser call that is targeted at the servlet automatically is forwarded by the web server to the servlet container, from the servlet container to the service method of our servlet. And inside the service method, the call of the browser is analyzed. And typically, if we just have, I want to watch something and I want to use something, they are just get and post requests. And the service method analyzes the HTTP request and then forwards the call to the matching do-get or do-post method. So those two are the ones we are interested in. The service method is not touched typically. We don't touch the service method. So don't do that. We just provide an implementation for the do-get and do-post method. And in the exercise, do-get is enough if you want. Yeah, so that's the thing. Do not touch the service method. I had very few students who tried that, and of course this didn't go well, and therefore we had problems finding the error because I didn't really realize it well. They really played around with the service method. This takes time and frustrates everyone, so don't do that. So how does a servlet look like in code? Quite easily. And this will be the last thing we do before we make a short break. So we take a look at the servlet method. We build our own Java class, whatever we name it, extended from HTTP servlet. And then we at least have to provide a do-get method or a do-post method. And of course, you can generate the code or generate the functionality and provide a do something method. And that does sort things out for both do-get and do-post. But the do-get method gets, if we take a look at the signature, what goes in, there's something like HTTP servlet request and HTTP servlet response. Parameters are provided, and as the name already states, everything that was provided in the request from the browser can be accessed by the request variable, and your response to the browser needs to be incorporated or needs to be provided with the help of the response parameter. And that's basically it. So in the response, if we take a look at the code, the response, we set the content type, then we get ourselves a print writer, and then we can print the response HTML page line by line. And at this point, you realize, what do we want to do? We want to provide an HTML page based on print lines. This doesn't look suitable and economic and fast. And of course, you're right. And that's also the reason why there are many top layer technologies on top of the servlets, because we don't want to do something like that. But in our exercise, we don't want to provide some fancy web pages. We just want to build a very, very simple web page. and therefore we will use that. And of course, you can provide some fancy methods and classes that do some of the work in the background more easily for you. So we print out our web page into the print writer, and then once this is conducted, the reply, the HTTP response, together with the web page as a content of the HTTP response, gets communicated to the calling browser, and the browser looks at our enormously interesting web page. Having said that, we now make a 5-minute break, and after the break, we take a look at the life cycle, and break will end at 9:56. So 5 minutes from now, we continue with taking a look at the life cycle of our Servlet technologies. Okay, till then, I will get myself a tea, and we see each other again in 5 minutes. Okay, back again. Let's continue on how to build a servlet. As I already said, the servlet itself is, how do I get away with this? Das Ding da weg, genau. The servlet itself is comparable with an Android application. So as every component-based system, so no, it's not activated on its own. So there is no main method that needs to be started. It's basically, it has some kind of lifecycle methods that the framework that is containing the servlet is using in order to trigger the servlet itself and manipulate the servlet and work with the servlet. And the life cycle of the servlet is that easy compared to what we do in the mobile world. So we have initialize, the servlet gets initialized, then every browser call is provided to the service method, and the service method decides, is this a get call, is this post call, is this update, is this delete, and whatever, put. And at some point in time, the servlet is unloaded from the system. And when it's unloaded, the destroy method gets called. And then the servlet can close some database connectivity stuff or communication gateways to servers it is using. So again, this is quite interesting, not relevant, because we can just kill the servlet and do not care if the servers in the background have problems closing their sockets and RMI communication stuff. But lifecycle in detail, when does the servlet get initiated? So when is the init method called? That typically is depending. Default is that the servlet gets constructed when the first time when the browser calls a URL that is targeting a servlet and not a static web page. Then the servlet container realizes, well, this is not this is something that has to be solved by the servlet, and then it constructs the servlet, and then it forwards the call to the service method of the servlet. So sometimes during the test in our exercise, you will see that the servlet is somewhat laggy. And that is the reason typically is that this thing needs to be started up when the first call comes, and the second call typically is quite fast, and the first call is a little bit slower. Or if you configure the servlet metadata correctly, then you can also state that the servlet should be initialized together with the servlet container. So when the servlet container gets started, automatically the servlet is also instantiated, so that this lag is not feelable when the first browser tries to trigger a servlet. Yeah. The init method gets automatically called, yeah, and inside the init method, you can state what should be done when you want to, when the servlet gets initialized. And sometimes if you're talking to a database in the background, you have to open up the database connection and later on close the database connection, or the socket connection, or the REST connection, or the RMI connection. And all this can be conducted in the init method. And then you can work with that, or inside the doGet and doPost method, wherever you like. The process client requests, we already talked about that. All of them go to the service method, and the service method then provides the call to the matching doGet, do something method, and so on. I already told you that inside the request parameter, every request related piece of information is contained, and you can use the associated method of this class to query them, analyze them, use them. And the response object is, as the name already states, responsible to generate a matching response. You can manipulate the response header of HTTP. You can provide the HTML or whatever content you want to provide. And then this is sent back to the to the browser, and inside the browser analyzes what is provided and then does whatever it does. The unloading of the servlet class, we can see that later on when we manage a servlet inside the servlet container. And if we unload the servlet, then the destroy method should be called. And the HTTP servlet request object is the class is something we will definitely have to use. Some aspects we have to use is getting the parameter from the URL or out of the form data of the post request. And we can use the get parameter with the name of the parameter that is that needs to be known in order to get our hands on some of the parameters. We can get the information about the client that is trying to get the web page we are constructing. We can get our hands on an HTTP session object, which we can use to distinguish different browser calls. Because something we will hear about later on is that HTTP is stateless, which means it's more or less like this UDP communication. Every UDP communication is the same. So we cannot distinguish between, okay, this UDP package is the second one, or at least not from the communication perspective, is not this is the second one from a client number one, and this next UDP package is the third package from the client number three. We have to do that kind of logic inside our program, and same goes for HTTP. So it's basically they all look alike. HTTP session object can be used to distinguish different client calls, different browser calls. So this is one technology to distinguish browser calls. We can use cookies, which is a less sophisticated and in corporate form subversion of the HTTP session. We can get, of course, all the HTTP headers by calling the header enumeration, getting our hands on the header name, and then using the header name in order to get the header content. Some kind of attributes, certificates can also be used, which are typically provided by the servlet container. Can query them, but this will not be part of the exercise. This is some piece of code you definitely will need for your exercise in the info servlet later on, where it's part of the exercise to get all the information about the HTTP request. This brings us to the response. When you have everything together and you want to send your reply, you need to call the get writer of the response object, and you have a print writer, and you can use the print writer to send the content back. So the print writer is for the content, not for the HTTP response header information. There are several other distinct methods that should be used on that behalf. But if you want to send back a web page, you have to use the print writer. So you can set the status of the reply. You can manipulate the headers of the reply. You can set the content type of the reply. Some kind of error status. You can redirect the browser if you want to. And you can add cookies to the client. And this is some piece of code that was from the first versions of this lecture, where we really built some Google Maps equivalent. And because then the structure of the modules were different, and we could really build a dynamic web page that was capable of showing maps in the browser and manipulate the browser, the map on the browser. So something quite similar to Google Maps, but of course way less sophisticated. Okay, this brings us to another example how an HTTP servlet could look like. And this time, this piece of code is relevant because here you can see how to grab some parameters out of the call of this web page. And so someone provided a URL call with parameters or a form where we had data that is targeted by the name X and Y. So we can extract them, parse them, and then work with them inside our response web page. And that's basically what is happening here. And this is also something you should do in one of the optional exercises. So this is a relevant piece of code. Of course, this thing here is the problematic part. And of course, this implementation isn't really a nice implementation. And if we were in one room, I would ask you why this is the case. But as we don't want to waste too much time, I would just tell you, because when this request get parameter X is when this not an X provided, or you provide a capital letter X, then of course this parameter is not found, and then of course null is returned, and then you try to pass an int out of a null, and we all know what then will happen. This will crash, and therefore some security aspects are still missing in this piece of code, but then it would not fit in this web page on this slide. And of course, this is the problem why I made this the way it is. So now we are capable of coding a servlet. The next step, as I said at the beginning, is, okay, when we have the servlet code up and running, we need to provide some metadata to the servlet container so that the servlet container knows what classes are involved, how to reach these classes, and it's comparable to the manifest file in Android. So something like the manifest file in Android is needed on the servlet side. And of course, the servlet is way older than Android, so it's more or less the other way around. In the beginning, we had a deployment descriptor named web.xml. And inside the XML file, everything was stated that was necessary to be known to the servlet container. But of course, this was the knowledge was in two files, and two files means two problems could arise, and therefore, with the birth of the Java annotations, also the servlet technologies used annotations. So the web.xml is not frequently used anymore. There are still some technologies that still rely on the web.xml, and we will see that later on. But the servlet technology already works without web.xml and uses annotations. And they were introduced in the version 3 of the servlets. And what the servlet container does, it just takes the class files, scans them, and looks for annotations. And when it stumbles upon a web servlet annotation, it knows, the class that is annotated with web servlet is the class that needs to be called when a browser tries to reach this servlet. And in order to make a decision which servlet is reached by which browser call, of course, this web servlet needs to specify the URL signature it is associated to. We see that later on when we take a look at how to reach a servlet with our browser. And therefore, one of the mandatory properties of the web servlet annotation is the value or the URL patterns attribute. And you can use that attribute to state what URL fragment is relevant for this servlet. So with what URL you are reaching this servlet. it is a fragment of the URL that needs to be used to trigger the servlet, but it's an important part. Aside from that, we have only one mandatory part, the name of the servlet. So an internally used name for the servlet necessary for distinguishment. And what you can also do is you can call a servlet can call another servlet that is inside the servlet container. So you can split up work just like classes with web servlets. The one web servlet is the entry point of the communication with the browser, then does what it is used for, forwards the call to the next web servlet, which does some other trick. And then there's a chain, and the last piece of the chain then sends the reply back to the browser that was doing the initial call. And in order to reach these other servlets, a name is necessary, a unique name inside the servlet container, and this needs to be provided. And then we have some additional optional parts that are also can be used, but not necessarily needed to be used. This brings us to some examples. So this is an example of a web servlet annotation for some kind of servlet. So it gets a nice little sounding name, perhaps a little description, and then a URL pattern which needs to be used in order to reach this servlet. As the plural already states, there are multiple ways to reach the same servlet. So you can use multiple different URL fragments to target the same servlet if you want to. And yeah, as you can see, you can load on startup or async support stuff. Some optional parameters can also be phrased. The important thing is that the web servlet is annotation is stated directly over the class that is extending the HTTP servlet, and then everything is fine. And then we have provided enough metadata to do the next step, and the next step is deploying the servlet. So now we have the code for the servlet, we have the metadata for the servlet, and now the next step is bringing the servlet up and running. And of course, we need, as we already heard in the beginning, we need something called servlet container to do exactly that. And the Apache Tomcat is the official reference implementation of a servlet container. So we are using that one and not some third-party alternative. Nevertheless, Glassfish, WebSphere, iPlanet, JRun are all capable of playing around with servlets if you wanted to use them. But we stick to Apache Tomcat because it's part of the XMPP package, and the XMPP package is available for all relevant hardware setups, and therefore we stick to that. So we will be using the Tomcat. It provides the core functionality of a web server, so it's a capable web server. But when you start up XMPP, you can also see that Apache is available, and Apache is, of course, the better web server, which is way more flexible and stuff like that. But in our case, we don't need to start up the Apache. We just need to start up Tomcat because we just play around a little bit with web server technology. Right, this brings us to the part where we take a look at the structure of Tomcat internally. So we have the binaries directory, surprise, surprise. We have the libraries directory where we already have taken a look at. And now we come to the other parts, the configuration files, which typically when you install XMPP for the first time is something we need to manipulate because when you initially started, you don't have administration rights. And then we need to manipulate one configuration file. And when we manipulated the configuration file, we gain administrative rights, and then we can use the management console of Tomcat to manage our servlets. And this is exactly what we want to do. This brings us to the next problem. When something goes bad in our servlet, then of course an exception is thrown. Typically when something bad happens in Java, an exception is thrown. And the problem is, of course, the exception is thrown and you don't see what is happening because the servlet is not running in your IDE. It is running inside the servlet container. And that, of course, is something, well, how do I get to know that something went bad and how do I know what went bad? And the good thing is, when we start up Tomcat, typically a window pops up that shows the current state of the Tomcat, and typically the exception is printed out in that window. And some log files are generated all the time. And typically the error that occurred pops up inside these log files. And therefore you have to check these log files. And the last aspect is the web apps directory, where the different web apps, the different servlets are extracted from their installation archives. And so all the code that is provided by the servlets resides in specific directories of the web apps directory. We can take a look at it. So let's take a look at the web apps directory, and we were in the library directory. So first of all, inside the configuration. So perhaps we manipulate the configuration first of all. So let's get rid of this because, of course, I have already done that. So this is the initial way when you, oops, you didn't see that because because it was done in a different directory. So I opened up the configuration, Tomcat users, and I had something written in here, but which I just deleted because it's a more realistic approach. So now when I start XMPP, I can see that I can start Tomcat. I have to install a new version. It's from 2019, so not the newest version. So it's trying to start up Tomcat. So when this is green, you know Tomcat is started. You know which ports it is using, and we are interested in 8080. Let's see. If I press admin, this window pops up. And when this window pops up, and you can either choose admin or you just close that and you open up a new one and set localhost 8080, column 8080, and you find this web page, then you know that Tomcat started and is alive. And then most of the problems have already been solved. So then we want to use the manager app. Okay, my browser still knows that. This should not be the point. I wanted to show you that there is an error occurs when I do that. And of course it doesn't do that. So let's clear the cache. How was it? Shift, Control, Alt. Let's test them all. So when I press now, when you do that the first time, then you get an error message. And inside the error message, there will be some XML code depicted. And this XML code that is depicted needs to be copied into the Tomcat users.xml file right in this line here. You copy it there, restart Tomcat, and then you can enter the management console. And that's basically how it is done. And when I restart my computer and I try it again, then everything is, then it will not work anymore. And of course, you have to choose your own password because a password is required. So what do we see here? What we see here in this web page are the different servlets that are up and running. I have already the Hello World servlet up and running. The important part is here, choose your local war archive for installation. And this is something we will do. And yeah, basically that is the case. And let's see. So this is the test Hello World servlet I want to show you later on. And as you can see, you can stop it, you can reload it, and you can unload it. And let's see if we can do that. Let's see if I have something that is already no. Of course, I don't have that. I want to go here. I need this directory. I need that. I want to show you. Okay, go to the configurations. So that was the configurations. In the web apps, you see that you don't see. It should be seen. Why is it not seen? Why is it not seen? Why is it not seen? It should be showing Hello World at least. Why is it not showing Hello World? Am I using a different directory? Tomcat web apps. Yeah, it's this one. So I was looking at the wrong directory. And as you can see, all these directories are available, and also Hello World, which is the servlet I just started before we got into this lecture. And when I then press delete, it is removed. And then it should, and it is also removed from the web apps directory. So it's gone, and this is basically what is necessary. Next step is taking a look at the log files. As you can see, the log files are built on or integrated on a daily basis. So you can see this is the log file of today, and it tells you what is happening. And if an exception occurs, one of these log files of today will contain the exception. And then you can take a look at the exception. It tells you in which line and something went bad and what went bad. And then you can take a look, and then everything is up and running. And you can check that out. Exactly. So this is what I wanted to show you in this situation. Right. And so we have the servlet container up and running. We can get to the management console. Now we want to deploy our web application. We can do that in different ways. We can change some configuration files that it always is using our compilation directory, but this is not really feasible. What is typically done is that you define code your servlet, and then you put everything into a so-called war archive. And this war archive is then used for deployment. And there are two different ways to deploy this war archive: a quick and dirty version, which you should not use, and a good version, which you should use. Nevertheless, we need to do this war archiving, construct this archive. Please try it out once or twice with the command line command. So there is jar command -cvef, then the name of the war file and everything else you want to put into that. The name you use here is really, really important for the exercise, because this name is also part of the URL that needs to be used to call the servlet. So the servlet is the machine which you want to reach. The URL of the servlet is, of course, localhost in our part 8080 / the name of the archive / and then the metadata inside the servlet, the URL fragment. And then you have a URL that is pointing at a servlet. So this is important. The name is that important. Okay, so we need to, we typically want to build a war archive. A WAR archive has a very, very distinct structure. You cannot choose the structure of the WAR archive as you like. You have to follow the rules. And every WAR archive contains a special directory, which is named webinf, capital letter minus used. And if you misspell that, it's not the same and it will not work. So inside the webinf directory, all the necessary content for your web application is contained, and it needs to be in a directory called webinf. And that is not enough, because in the webinf directory, there are subdirectories involved. And the most important subdirectories are the directories classes, plural, and lib, singular. Even if you put multiple libraries into the lib directory, it's still singular. And why they choose singular and plural, I don't know. So classes contains the classes of the application, and the package structure of your class needs to be taken into account. And of course, every class uses a package structure. There is no way around that. And the library directory, of course, contains additional libraries you use in your servlet code. And in the old days, the web.xml was part of the content of inside the webinf directory, but from version 3 on, we are using the annotations, and of course, different other configurations files were also put in there. So how does the archive or this directory structure of a servlet look like? Important one, webinf. There is a webinf subdirectory, and inside the classes directory, there is your servlet class and additional stuff you use inside your servlet class. It is inside the webinf classes. Inside the lib directory, there are additional jars that are necessary or used inside the servlet. The servlet jar doesn't need to be provided. But if you're using PostgreSQL database in the background, for instance, then you need to put the PostgreSQL library into the lib directory. In addition, on the same level as the webinf directory, you can put an index.html, which contains, for instance, a link to your URL that calls the servlet, which makes your life easier. So you don't need to write down the URL all the time inside your browser window. So this is a nice optional part. These are mandatory. This one on top is optional. This one is mandatory. And the other one just shows you stuff that may be involved, but we won't be doing Java server pages in this lecture anymore. So how does the index.html look like, or could look like? And so this is the call of the servlet. In this case, of course, it's a very simple one. This may, of course, differ and depend on your implementation. So how to deploy a web application? We need to construct the useful directory structure of the web application with webinf classes and library. If necessary, construct a useful index.html. Inside your IDE, it is a good thing to redirect the build directory, so where the IDE puts the class files in, and you want to redirect it into the webinf classes directory, so that inside the webinf classes directory, always the current class files of your web application are residing. If you're not doing this, then you always have to manually copy them from the build directory to the classes directory of your web application. And of course, this is one step too much. Then when you know, when you have these build directories and the directory structure up and running, you need to construct the war archive based on the directory. And then you have two versions to deploy that. Version A, brute force, don't do that. You can copy the war archive to the web apps directory of Tomcat, and Tomcat will realize that something was dropped into its lab and it will use that. This is not the good manner, and we see a demo later on. And we have a useful version B where we use this management console, and where we already see or saw that we can start, stop, and delete the servlets. And as time is already sparse again, we go one step further. So how to reach a servlet? As I said, we have to trigger the servlet container. So in our case, localhost 8080. And then we use the name of the war archive. And then we have to add additionally to the war archive name the URL pattern we stated in the servlet annotations. So this is also part of the URL. And then we can add parameters if we like to. And if we state it correctly, we will reach the servlet. And if we state it wrongly, then we get an error message. And let's take a look at how does this look like in code. So before we are through, so what do we have here? What I typically do is inside my project, we have source, we have the binaries. And as I can see the binaries, some of you already know, the IDEs typically hide the construction directories, but now I can see the construction directory because I redirected the construction directory of the project. What I have here is the web content directory. And the web content directory I use to store the content of the servlet. So I have a webinf directory, I have a lib directory, and I have a classes directory, which we could now not see because it is used by the IDE and therefore it is hidden. We can the old deployment war archive, which we just delete, and we have the index.html, which I use to execute later on the servlet. And as you can see, I'm just adding run to the current URL we are residing. And as you can see inside the servlet implementation, run is one of the aspects that can be used. What you can also see here is this /star. This is a wildcard, so you can spare the additional URL fragment that needs to be put to the end of the URL. And every URL with the name of the deployment war archive will be used then in order to trigger the content of the execution of the servlet. Right, so let's just quickly source. As you can see, I didn't choose the default output folder. I redirected it. So typically it's binaries with Eclipse, and take a look at the structure here. So once I apply that, binaries should be hidden. And as you can see, binaries is hidden and classes pops up. This means in this scenario, when I code and this code gets compiled, the classes go into the binary directory. But what I want is I want them to go into the classes directory. So I want them to go here. So what I do is build the right directory structure, then rewire the build directory to the classes directory, apply that, yes, and then the classes directory is hidden. but it's still there and used by the IDE to put all the classes into that. And once I've conducted that, I can go to the web content directory. I can go to the webinf directory. I can go to the classes directory, and inside the classes, classes. And as you can see, there's something in there because it's rebuilding the package structure. Or how to build my jar archive. I want to put index.html and webinf into my jar archive. So I'm doing jar cvf hello world.war. This is the name of the war archive, and I want to put index.html into it and webinf. When I press that, everything gets integrated. Hello World War is prominent in this directory. The next step is going into Tomcat, going into the management console, and then choosing local war archive installation. I search for the war archive, I choose the war archive, I open the war archive, I install the war archive, and then if everything runs as anticipated, the name of the archive pops up here, and started is pointing to true. Then you know your servlet is up and running. Then you can press here. Then as you can see, your URL has already been defined to machine war archive name. And if I now press foo, you see I executed my servlet because as you can see, this is exactly what I'm stated here. This is the way and some kind of counter mechanism. And so this is a possibility, or I choose my index.html, which is depicted here. And this uses not foo, but run inside my property, inside my URL. And this is the way you can start a servlet. And this is the way you should start a servlet. Build the war archive manually until you know how to do it, and then for goodness sake, you can use a nice little plugin that does everything automatically. But you definitely need to know the structure of the webinf directory inside the XAMPP. And if you don't know that, you will miss some points, perhaps, and you will need them. So, but I think now lecture time is up. So we again close down the session, and I will open up the exercise channels. For the automotive computing students, and for those of you who will not attend the exercises, happy Christmas and lots of drinks and lots of food and lots of relaxing days. And hopefully you get good into the new year and not with too much headache. So, and the others, of course, for everyone, same wishes. See you, some of you in the next year and the others inside the exercises. Bye.